Okay. So we are now recording, and I'd like to officially welcome everybody. we we have made it here, and today we're going to be talking about Mars. It's going to be our main focus, but that's not the main point. It's going to be a lot of technical detail about Mars, but the real main point is come here, that God gave us uh, this earth, and He created it to be inhabited. Now, the implication of this, being written thousands of years ago, is that there are places that were not created to be inhabited, and I would suggest to you that Mars is one of those places. So we're going to look at that now. Last year in April, and I've done this a couple of times, but because in April we have Earth Day coming up on the 22nd. So, in honor of Earth Day, we'll take a look at the planet Earth and the evidence that it gives that God is, in fact, um, involved in the whole process. I'm going to do one other thing here. That's a little better. Okay, so I am not saying uh, that we should not go to Mars. Okay, we can go to Mars. I think we will end up having people go to Mars, and some of them may make it back.
Yeah.
You know, I've said before, Elon Musk has said that he wants to die on Mars, just not in a crash landing. And I am confident that the planet Mars will be glad to accommodate it. So
I mean, we went to the moon. It's even a harsher place.
maybe not. We'll see.
Not as far away.
We'll see.
Because
Uh,
of this,
I'm not saying that we cannot go to the moon, okay? And I'm not saying that the problems that we're going to talk about can't be solved, okay? What I am saying is that good life support plans are hard to find. Okay, this is not going to work out well. I'm saying that Mars is a case history here, a case study in planets. So we now have thousands of exoplanets that have been discovered, and we don't know much about most of them. We know very little about most of them. So here's one planet that we know a fair amount about. So it's an interesting case study. Um, and I'm saying that we should appreciate the Earth because God has given it to us. Okay. So all the detail we're going to go through is is really not just about the minutia of Mars. It's really about appreciating what God has given us in this planet. And I would suggest to you we are never going to rule Mars like we rule Earth. That's in part because we're told to rule over the fish of the sea. There ain't none on Mars. The birds of the sky, there aren't any there.
It's a lot easier to rule Mars
Yes, there's not much to rule. Yeah. So it's not going to be the same. So let's talk about these. Maybe I should look over here. I'm going to switch because I could then. Um,
Make sure you're still in the camera.
am I? Am I still in the camera? I'm still barely in the camera. Okay. So let's take a look at Earth versus Mars. Just kind of cover some high level issues here. We're the third planet, the fourth planet from the sun. 93 million miles from the Earth, 128 to 155. That's because the Mars's orbit is more elliptical than ours, so it has a greater uh, range, and that affects, of course, the temperature variation from year to year. Diameter: Mars is slightly more than half our diameter, but is quite a bit less dense. So its gravity is actually about 0.38, a little bit more than a third of our gravity. So let's just take a look at a couple of pictures here, some scenic views from Mars. There you go. There's another one. And this is the whole planet. The whole, this, you know, you travel around Earth, and you can get all kinds of different habitats, and but that's it. Here's a dust storm. Ah, now these dust storms come up regularly, and they can last for weeks, and they can in fact cover the entire planet. Okay, so in May you could take a look at Mars, and July 1, same year, the whole planet is covered in dust. Okay, so it's not really a sandstorm; it's a dust storm, because the kind of dust we're talking about is like talc, and so once it gets airborne, it doesn't take much to keep it airborne, and it gets everywhere. Okay, so this is the planet we're talking about here. Gravity, I already said it's 0.38 Gs. A day is almost 24 hours. Okay, so but the year is 687 Earth days. Okay, so what that means is your winters are long. Okay, and by the way, winter may be cold, but summer is also cold. Okay, so the influx, uh, uh, we give the Earth one. The solar influx, the heat, the light you get from the sun is less than half of what you get. This is, of course, an average. Yes.
Does Mars tilt on its axis?
Yes. Yeah, it does. In fact, that is um, it's coming up here somewhere, and it's very close. It's close to it's in the 20s.
Really?
Yeah, yeah, like Earth. The orbital eccentricity. You'll see the orbital eccentricity. It's about what 6 times yeah, what the Earth is. So it's more elliptical, which makes the temperature change over a year more. So the average temperature, and of course, remember, can be deceptive. A 6 foot man can drown in a pond that has an average depth of 2 feet. Okay, so averages don't always tell the whole story. But this tells you something. The average temperature on Earth is 59 degrees Fahrenheit. I counts the poles, the equator. On Mars, it's minus 81. But look at the temperature ranges. On Earth, at the equator, from 68 to 95, typical. It'll get hotter. But on Mars, minus 94, but it'll get up to 68 degrees Fahrenheit sometimes at the equator. Okay. Now, there's some issues. Don't just say, "Okay, great, it's shirt sleeve weather." Now, hold that judgment.
Shirt sleeve better with the spacesuit on.
Yeah, shirt sleeve with a spacesuit on. Right. So the poles temperature range is minus 195 to minus 22.
Ooh.
Okay. So we are never getting up much. But look at the difference in range there. And the issue here is that the temperature swings affect all kinds of things. Because you have, from an engineering point of view, you have a swings, a expansion and contraction kind of function that affects metals and all kinds of things. So the temperature fluctuation is also an issue. Okay, now here's more than 6,000 different minerals are known to exist on Earth. After 50 years of investigation, only 161 minerals have been found on Mars. Now, why is that? Why do we only have the 150, 161 minerals on Mars? Because Mars does not have the complex geological features of plate tectonics and the weathering and all the kinds of things that goes on Earth. And does that make a difference in what you can do on Mars as far as mining and things like that, things that you can find? It certainly does. So I'm just saying that there are some significant differences here. And if you say this is just a case study, if you look at all the other planets, people are saying somewhere out there's another planet like Earth. Well, maybe not. Maybe this is a significant difference here. So there are a bunch of Mars enthusiasts, and they say, well, we need air, water, food, and shelter. We can solve all these. Okay, we're going to look at those. But Morgan would say we need the air, water, food, shelter. But the shelter issue here, I'm going to say we need protection from temperature in ways that we don't need it here on Earth. We need protection from radiation in ways that we don't need it here on Earth. Regolith and sandstorms, we're going to talk about regolith a bit, and perchlorates. And you're also going to have light because it's going to be dark for a lot of period of time. When you have sandstorms, you're going to get it's going to get dark. If you're uh, away from the equator, you're going to have long periods of darkness. If you were at the poles, you would not have 6 months of dark. You'd have a whole year of darkness.
Do we have a, don't we have an atmosphere that protects us
Yes, well, yeah,
that they don't have on Mars?
yes, we absolutely do, and we'll be getting into that also. So there's some other things that you're going to need to have high tech energy. Here on Earth, sometimes you can get by with a fire. Put a fire in the fireplace, and we can make do. I can even cook hot dogs or whatever I need to do with a fire in a fireplace. Um, in on Mars, everything is going to be high tech. There is no such thing as low tech survival on Mars. Okay, let's take a look at the facts. The air. The composition of Earth is 78% nitrogen, 21% oxygen, and 1% other stuff. Okay, but look at Mars. 95% carbon dioxide, 2% nitrogen, call it three if you want to, 2% argon, a little bit of oxygen, not much.
2% argon.
Yeah,
Not odd.
yeah, it's curious, but that's what they've got. But look at the atmospheric pressure. I have 0.01, 1%. I have seen other places that say 0.6%. But anyway, it's two orders of magnitude less. It's as if you were at 125,000 feet would be approximately
All the time.
all the time. Okay, so there's not there. Now this does a couple of things. One, when the wind blows, even if it's a 60 mile per hour wind, it doesn't have much force because it's not very thick. So it'd be like rather than having a fire hose hitting you, it'd be like having a spray hit you. So even though it kicks up this dust, it's really fine dust. It's not moving, not like a big sandstorm sandblasting you. It's a very different thing. Okay, and we talked about the temperature a little bit earlier there. Okay, air on Mars, the plan. Let's go to Mars. Well, there is actually on Mars right this minute a piece of equipment called MOXIE, and it is going to be using in situ resource utilization (ISRU). So the idea is to figure out how can we use Mars's resources to survive. And MOXIE will process the carbon dioxide that's in the air, and through a process will produce oxygen. So carbon dioxide has got two oxygens, but so it puts out carbon monoxide. So you have to exhaust that, but it's working and it produces oxygen. It's
And you add that to the already crappy atmosphere they have.
well, no, you're going to add that to your habitat and use it for your spacesuit. Okay.
No, I mean the carbon monoxide.
The carbon monoxide gets
So
added
you're
to.
now making the crappier atmosphere even more crappy.
Yeah, just a little bit. It probably wouldn't be noticeable. So anyway, if you scaled Moxie up, ran it for 20 months before the humans arrived, you could produce 20 to 30 tons of oxygen for astronaut breathing and for rocket ascent for return. So this is the plan. We will send these Moxie units ahead, and they will automatically produce all this and store it in tanks on Mars, and it will be ready for when the astronauts show up 2 years later. Okay, that's the plan. Nitrogen, where do you get it? Bring it from Earth. Now, we breathe 78% nitrogen. Well, why not just use, you got the oxygen, why not just breathe all oxygen?
No, you can't do that.
Well, there are some.
For a whole lot of reasons.
Yeah, there are a number of reasons. Actually, I've got a slide on it. Or you could try to pull it from the atmosphere, but that is really hard because there's not much there. And it's going to take a long time, and it's going to take some really heavy equipment, to do this. So Mars habitats might have 50% oxygen, 50% nitrogen at one half Earth pressure. Okay, so we're not trying to replicate the Earth atmosphere. we're trying to do what's possible. But you still need 50% nitrogen. Okay. Now, what would happen here? I'm sorry. But you also have various contaminants that you got to get rid of. So that as you try to pull out, say, the nitrogen and the argon, actually you can do this. The way you do it is you cool it down. The carbon dioxide liquefies first. You get rid of the carbon dioxide. You're left with mostly nitrogen and argon, both of which are inert gases. So you can use a nitrogen argon mix, but you still have to then get rid of the other inert things that are there. And so it's not a simple process. It's not as simple as freeze it and get rid of the carbon dioxide. There's more to it than that. You need scrubbers and filters and maintenance and replacement. It's high tech for survival. Why do you need something other than oxygen? Well, this is a list of various kinds of materials and where they will burn. So you have cotton will burn here on Earth, 21% oxygen. So will polyester. Wool, you have to get it up to around 30%, in which case then you cross it off the list if you have 30% oxygen. So if you have 50% oxygen, you're going to have some dangerous materials here. So it's using 50-50 is problematic. That high oxygen is also irritating to the lungs. Oxygen is an oxidizer, and we all should be eating a lot of antioxidants. Okay, so if you increase the oxygen because you don't have enough nitrogen, then you're going to be going to some problems. So you might do better to try to get closer, 60-40, 70-30, something like that.
Did you say that argon is more common than nitrogen, though, in Earth's atmosphere?
No, not in Earth's atmosphere.
No, not Mars. I mean,
On Mars.
Yeah. Why don't they just pull argon in instead of nitrogen?
Well, if you're going to pull the carbon dioxide out, you're going to be left with nitrogen and argon. So you might as well take them both.
Yeah. Yeah. Okay.
The argon is also much heavier.
Yeah.
And if you breathe some argon, I've done that. And
It's
I
hard.
go to get up off the floor and I'm almost back on the floor. What you do is invert. You go upside down a bit and all that rushes out. That's how heavy it is.
Wow.
That's why it stays on Mars, because it has a little gravity, but it's a heavy, heavy gas.
Yeah.
And there's an atmosphere of argon on the moon.
Oh,
It's
really?
the only gas, very, very thin.
Yeah.
But it's the only gas that will actually heavy enough to stay there.
Yeah.
It's that heavy. So that's another reason
So it's probably not very
the best thing.
good to do. If you had neon, it'd be different. But
Yeah, I don't understand the green and check marks in the red.
Okay, so the LOI, the limiting oxygen index, you do an experiment and you say, we're going to start something burning and we're going to start reducing the oxygen until it goes out. And so you can then see that wool and these other ones down below are okay in 21% oxygen. They're not a fire hazard. Okay, so but if it's got a red X in it, that means it's a fire hazard in 30%, or it's a fire hazard at 34%. I see. So the higher you go, the more things become fire hazards. Okay, so but you're going to have to deal with this if you're going to live on Mars. You have to say we're going to have an atmosphere that has X percentage of nitrogen or some inert gas plus a certain amount of oxygen, and then you have to manage that. Okay, and it's got to be managed with high tech. That's the point here. This is not move-in ready. Okay. Mars versus Earth. Mars, you're going to ship nitrogen from Earth. Earth, you just breathe it. You're going to make oxygen from CO2 and water, or water, because you can use hydrolysis to get it from water. Earth, you just breathe it. You have to have airtight habitats, or it doesn't work. Earth, it doesn't make it. Have a screen door if you wish. Okay. Airlocks at every entrance. Screen doors, revolving doors, whatever, open windows. On Mars, you need to have scrubbers and filters to, if you were to cook something, have any sort of outgassing of any kind of equipment, you need to have scrubbers and filters. On Earth, we open the windows. Okay, This is not a low-tech survival at all. Let's talk about water. Mars does have water. There's no evidence that there's liquid water. People write about it that maybe there's water that has enough salts in it to where it hasn't frozen yet, maybe deep down. Okay, maybe it is. We haven't found it yet. So
It's at the poles, right?
yeah, it's known to be at the poles, and there are craters that have water in it, so you can get it, but it's not like you froze distilled water. Okay, this is dirty water. It's
Very salty.
in fact the term they've used is frost grit. It's got sand, so you're going to have to use a backhoe or something to scoop this stuff up and then heat it up, distill it, and oh yeah, we can get water in the Mars. And as soon as you say there's water in there, the problem is solved. No, the problem is not quite solved. It's all frozen. You got to transport it by vehicle. You got to melt it. It's got regolith dust in it. And it's got perchlorates and salts of various kinds that are all soluble that you have to get rid of. What are perchlorates? Calcium perchlorate, magnesium perchlorate. A perchlorate has chlorine and 4 oxygen molecules.
It's like a bleach almost. It's
And
very oxidizing.
yes, it's very oxidizing. It kills plants. It messes up your thyroid. It messes up your lungs. It's nothing that you want to deal with. And as best we can tell from spectral analysis, it's planet wide,
Really.
everywhere.
Perchlorates.
For chlorides. Yeah, for chlorides. So when you
It's like-
when you get this,
My God doesn't want us to go there.
when you get this, when you scoop up this frost grit in your backhoe and transport it to your water purification facility, you're going to have to distill it, which will get rid of the perchlorates. Or people say, well, you could rinse the perchlorates out if you want to use the soil. Well, that's true. If you want to use the soil, then you have to rinse the perchlorates out with water that you just distilled, I guess, which all of which can theoretically be done. There are also people that say, well, we have bacteria which will process the perchlorates. And the answer is that is true. It's a yes, but those bacteria can't survive in the concentrations of perchlorates that you have in Mars.
Plus, the atmosphere is terrible for bacteria.
Yeah. So but even if you brought the soil into a place with a different atmosphere, the the bacteria still would have a hard time because of the concentration. Okay, melting takes energy. Uh, Purifying takes energy. Keeping it liquid takes energy. And using it, have to use it for consumption, bathing, plants, cooling, and for fuel. If you're going to produce hydrogen and oxygen and then put it back together, use it for fuel, you're going to take energy to produce that fuel. Okay, and the reason to do that is because you can use a whole lot of energy really fast, whereas electrical would be slow. So those are how water works. Mars versus Earth. Mars, you got to dig it into the regolith, the frost grit, transport it, go through this process, distill it, move the purified water to where? To your water tank.
Your habitat.
Where's your water tank? Every habitat probably is going to have its own water tank. It means you have to have a water supply system for every place. Okay, are you going to put piping out at minus 60 degrees? So you got all kinds of engineering issues that are involved here. On Earth, you know what you do. You turn on the tap, right?
Or you go down
Because
to the
we have
lake,
water.
get some.
We pump it up into these big water towers, and talk about water pressure. What if your water pressure were about 1/3 what it is? How would you turn on the faucet? The water just kind of comes on out very slowly. Okay. Well, this is what you're going to be dealing with, and so what they do in the space station ISS, and what you need to do on Mars is you would have a water tank that has a bladder in it, and then the bladder is pressurized to push the water out. Okay. So again, I'm not saying these problems can't be solved. I'm saying everything is high tech survival. Okay. So this planet was not made to be inhabited.
by us.
Yeah. Okay. Food.
When you say recycle water, that's also a perspiration and evaporation
Oh.
that has to be recycled from the air inside the habitat.
That's right. In the ISS, we have technology which does this. If you take a leak, you use the bathroom, whatever you want to do. You want to reclaim every drop of water that's there. Somebody gets sick and throws up. You you want the water. This
Yum yum. Yeah.
this is how it is. Okay, food.
Like doing.
Mars has no plants. Okay, so people say, well, we will grow them. Okay, we'll have a discussion about that.
Just the
Mars is nitrogen poor. The plants that grow here get their nitrogen from the atmosphere. We have nitrogen fixing bacteria, um, but it's not an easy task actually chemically. Okay, so that's why you have specialized bacteria to do it. Uh, the crust, um, uh, Earth has about 1.5 times more nitrogen in the crust than Mars does. Perchlorates kill plants. Okay, so
Even before you get any plants, you get plant killers in the soil.
yeah, so if you're going to use Mars soil and not try to transport Earth to Mars, you're going to have to get rid of the perchlorates. Okay, and then it's still not soil; it's regolith, which we'll have some pictures of coming up in a little bit. We don't have any nitrogen fixing bacteria. We have to bring those, I suppose.
Those you can bring with
It
you.
has no animals. So what? Let's see. We're going to ship a cow to Mars. How does that work? And
As soon as
how
you
do
open
they
the door, he's dead.
how do they cooperate? Marslings are going to be vegan. Okay, let's just sort of acknowledge this. I don't. One option might be frogs. Maybe we can take some hybrid frogs that have been eggs that have been in suspended animation, and we can raise frogs. I don't know how that will work. But this
What are you having for dinner tonight? Frogs again.
this is a delicacy. This is a delicacy in some places. Okay. Now there's some issues here. Vitamin B12. Your biggest source of vitamin B12 is red meat. Okay. Omega threes. Mostly the biggest source is fish. Trace minerals. The forms that the trace minerals are in the regolith is not bioavailable. So even to plants, because we have all these different kinds of minerals and things like that we have in our soil that Mars doesn't have. So we are going to have some issues with food. Mars is going to be mostly freeze dried, brought from Earth, at least initially. They're going to say they're going to grow some stuff, and they've been trying to figure out what they can grow. I'm sure that people spend a lot of time on it. But once again, you have limited water. Okay, say you're going to have hydroponics. Hydroponics assumes a fair amount of water. You have poor soil, expensive lighting, and expensive heating. Big energy demands. Okay, and there are all kinds of possible solutions. There's one solution that I read about shows this big greenhouse. It's covered with uh, regolith on the top to protect from radiation. Okay, you need radiation protection, and so it's got these big curved reflectors to reflect the light, and so you can have the light coming in, and somebody's done some calculations, and on a sunny day that can work. Tell me about the winter, and tell me about the sandstorms. Point. Oh, wait.
They're going to grow it in soil from Mars. Is that what they're planning on? They bring the soil from Earth.
Well, they are planning to remove the perchlorates from the Mars soil and use the Mars soil as base and enrich it.
It also has 40 times the sulfur that Earth has.
Yeah, there are all kinds. Yeah, there are all kinds of issues that are here. So, I'm not saying we can't solve these problems, but I'm saying this is not Earth 2.0. Okay, and this is not where you go for your honeymoon. Okay, on Earth you get, what do you want? Fresh, frozen, canned, freeze dried. You can have freeze dried here on Earth. I've got someone, in my own house, because I'm a little bit of a prepper, so I've got some freeze-dried food. You can have local, you can have imported, abundant resources, all kinds of plants and vegetables, animals. What do you want? Not the same. Protection. Let's talk about radiation. Mars has a thin atmosphere that Maureen mentioned it already.
And no magnetic field.
No magnetic field.
Not much.
No. Okay.
Very
Now, general radiation is 2.5 times Earth. Okay. And there's no protection from coronal mass ejection. So if the sun has a big, massive ejection, they're rare, but it's possible death within hours.
Oh God.
Okay.
matter
So
what
what
you
you have to
wear.
have is you have to have a coronal mass ejection warning system, and you have to have enough time to get into a protected area. Okay.
Deep underground. Something.
Well, yeah, you either have your habitats need some meters of regolith piled on top, okay, or some way to protect its way.
Also, just a trip to Mars, staying long enough to get to the right orbital incident to get back to Mars,
They need shielded.
you'll pick up, if I remember correctly, 70 rems of radiation.
Just
get
get
above.
Yeah, we're not. I'm not talking about getting to Mars.
Yeah,
I'm just
just
talking
on
about
Mars.
Mars.
Okay, but just if we're
Yeah.
getting there, and just the trip there and back, you get 70. I think it's either 70 a year or 70. I think it's 70, and that is anything above 5 is a cancer, really cancer risk. It starts going up, and so you're going to be in big trouble even getting there and back, let alone staying there.
Yeah, it's just going to be a challenge. And if there's coronal mass ejection while you're en route, there really is no protection on the ship that is good enough
You have to have steel.
to protect you.
I mean,
So
it take a lot.
okay, so the habitats probably will not have much in Windows, at least not at first. Now, if you do search, I've got some pictures later of proposed Mars habitats. A lot of them show these big picture windows, and spacious living rooms and things like that. You would need to have a overhang protection. To protect from the radiation, but the radiation, just like light hits the ground and bounces into your house, so does the radiation. And so it may protect you from some, but not from all. And so I think the norm is going to be small windows and maybe none. Okay, this is not how I want to live. I like to open up the curtains and let the sunshine in.
But it's not from the sun that's the problem. It's the heavy nuclide cosmic radiation is what kills.
coming from where?
From all over the universe.
Yes, from supernovas.
Not just the sun.
Not just the sun. No. Yeah, Wayne is correct. The issue is not just the sun. The issue is the cosmic rays that come from the cosmos, and our radiation, our magnetic field protects us. Okay, in the absence of a magnetic field, it's there. It's all the time. You can live with that for a fair amount of time, but if there is a coronal mass ejection and you are not protected,
You're dead.
you will die. Okay. So, temperature. You look at the equators and the poles, and you look at the variation. Uh, in Gale Crater, it has ranged from 68 to minus 220 degrees Fahrenheit daily. Okay. Now understand here that because of the thinness of the atmosphere, heat transfer does not work like it does here on Earth. We're going to get into that when we talk about spacesuits.
When there's that much temperature variation, is there a lot of wind?
Well, the wind, because the atmosphere is so thin, the wind is always gentle. The reason you get these dust storms is because the dust is so fine, it's like talc. Sun to shadow can be 60 degrees Fahrenheit difference.
I'm sorry. Oh, it's moving into the
That's
shade.
right. You're walking into the sun. There's a big rock. You step into the shadow of the rock. 60 degrees difference.
So if it was 68 out there, it's now 8.
Yeah, that's right. So I mean, this stresses whatever systems that you've got. Okay. You still need cooling, though, and that is because the air does not transfer the heat. So you're out there in a spacesuit, you're generating heat inside the spacesuit, and there's not enough air to carry the heat away by convection. So you need to have cooling. But in your fingers and your toes, you need heating. Okay, so there you have some issues here with the spacesuit. We're getting more of those a little bit. So you have cooling for the body, heat for the hands and feet, and you have a battery power that which would last about 8 hours max. So one of the things about these batteries is that they have to stay warm themselves. If the batteries freeze, then you have a problem. So the battery uses some of its own energy to keep itself warm.
They don't last long, do they?
Okay, and this has implications for your battery operated vehicle, which you parked in the open garage. Okay, and you don't have a heated garage. Well, that may not be good for your battery. Um, so the regolith, let's talk about that. Look at that over there. There's sand. This is regolith, Mars regolith, and you notice how abrasive that is compared to sand. Sand in your shoe is going to be abrasive, but this is even more abrasive. There's a little piece of moon regolith. And when the astronauts were on the moon, and this regolith, both on Mars and on the moon, is electrostatically charged. So it sticks to stuff. And the moon astronauts would get it on their visors and they go to wipe it off. They had these gold plated visors to protect them from the glare. Takes the gold plate right off.
Oh, man.
Okay, so this is nasty stuff. Okay, but this is what you're dealing with on Mars. Can we get a work around it? I'm not saying we can't. I'm simply saying this is not Earth 2.0. Protection against the regolith. It's fine as talc. I've said a couple of times. It's abrasive because of its roughness. It sticks to everything. Gets in the joints of whatever it is that you've got in your spacesuit. Dust storms can last for months. So habitats need an airlock tunnel through the regolith. You probably need to have a foyer that may not be airtight, but which is regolith clearing, so you can get out of a sandstorm quickly. And then you don't want to open the actual airlock if there's a sandstorm going on and get all that dust into the airlock. So you would want to have a dust block of some kind before you have the airlock.
You need air to blow the dust off of you.
Yeah, it's just something that you have to deal with. So you're going to need to have these multiple locks. Apollo astronaut Gene Cernan said dust is the number one concern. It sticks to everything. They would track it back into the lunar module. They would breathe it. It would be irritating to the lungs. Yet because it's electrostatic, it can float in the air. There are all kinds of bizarre things that start happening. Notice here the picture of this. This is the wheel of curiosity, and after a little more than a year, the regolith would tear it up. It's very abrasive, and here's one of the issues I never thought of until I researched some of this. The low gravity makes it worse because you can't get traction. So your wheels spin, and it's like sanding it. It's like sandpaper all the time. Okay, so once again, can we design around this if we know the problems? Wayne.
From a design engineering standpoint, all these factors that you're mentioning, okay, if you design to correct one of those things, the solution to that might cause 3 or 4 problems and other things that occur. And the more of these things you have, it becomes incredibly difficult to make the whole system work.
Yes.
They have interactions of various things, and it could be what's good for this is harmful for these 2 or 3 other things, and what corrects that harms this over here and that. Yeah, it's like a chain reaction. It's terrible.
So anyway, when you got to, was it Perseverance? That was the next rover. They made the wheels thicker. Okay, so now that we know, we can design around this. Use a different metal or something like that. It's possible to do this, but it's expensive, and you have to do it. About perchlorates. I mentioned before, it's a chlorine plus 3 or 4 oxygens. Typically, yes, calcium or magnesium. There's also a sodium perchlorate. Um, Mars has zero point 0.4 to 1% by weight everywhere. Earth is typically 0.0001%. In the Atacama Desert, it gets up to 0.1%. So at best, it, Mars's best is 4 times worse than Earth's worst.
Anybody know why there's so much perchlorate on this planet?
I think Earth has a lot of substrates that perchlorate will break down in. I think mainly.
Yeah, water I think will affect it.
Yeah.
But
And
you have a lot of
matter.
ionizing uh, ultraviolet light that comes in that doesn't get filtered out.
And organic matter, perchlorate oxidizes, but in the process, it's destroyed too. So
Yeah. It just doesn't have anything to interact with. It's just there.
yeah.
That's amazing.
Okay, so Mars has got 4 to 10,000 times the amount that at the best case
And the
form.
fact it's everywhere. I mean, we're a mess.
It's everything. It's water soluble, so it can get into your water. It kills plants. It's harmful to humans. You get hypothyroidism, general oxidative stress. It damages the liver and the kidneys. So you do not want this in your habitat. Okay? But it is going to be on your suit. You go to the beach and you say, "We will have no sand in our beach house." Right. Okay. We would say we will have no regolith in our habitat.
Yeah.
No, not happening. Not happening. Distilling the water, the water should work. That takes energy, of course. Protection. Let's suit up. Wow. Okay. Here's what you have to do to suit up. The astronauts who go out for an extravehicular activity (EVA), they have to do this. You pre-breathe the oxygen with a mask because you have to get rid of the nitrogen so you don't have issues with the bends when you go to a lower pressure. You put on the mag, which is an adult diaper. It's called the maximum absorbency garment. Okay, and this is because you are going to be out there long enough that you are not going to be able to hold it. It's not on the list here, but you will use what they call a low residue diet before you go out. So you're going to eat stuff that's not going to get through your intestines very fast. Okay. Um, you you then put on the MAG, the maximum absorbency garment, and then you put on the EMU, I'm sorry, I missed the cooling. So the LVGC, which is the liquid ventilation and cooling system. That is a bodysuit, like a wetsuit, but it's got uh, meters of cooling tubes all through it, and there's a pump in your system. You're just going to pump water to cool you, okay? And this is form fitted. You have one specifically for you, and so you don't just check one out. You have to have these made for you. If you gain too much weight, this is going to be an issue.
Sounds like on Mars you're gonna be losing weight.
Yeah, well, so I'm not sure how they'll handle that. But anyway, you have to put on the MAG and the LVGC. Then you put on the EMU, which is the extravehicular mobility unit. You can't call it a spacesuit. You got to call it an EMU. Okay, now, and then you check for lock or leaks, and you decompress. All that takes you um, 3 to 4 hours for those steps. Now you haven't even done any work outside yet. Okay, then you're going to go outside and you're going to do some work, number 5, and then you're going to come back in. You go back in the airlock, you have to recompress, clean off the regolith, you have to remove the suit, remove the LVGC and the mag, which may be messy, right? Because you couldn't hold it. And you're going to then clean those, and that's going to take you 3 to 4.5 hours. Add that up, that could take you more than 8 hours, and you haven't done any work yet. All that work, all the other time is going to go into number 5. Okay, so you are exhausted just from
A walk in the park.
just from going out. Okay.
Yeah.
Now, by the way, this is a team effort. these steps you can't do by yourself. So there is no modesty in this exercise. Okay, you are going to be naked with your teammates while you're putting on all these things and doing the pre-breathing and whatever. So if you don't pass the lack of modesty test, you don't make it on the team, and you kind of get close to your teammates. Uh, just this is just the way it's going to be. So some more points here. You can see that a short EVA is not worth it. I'm going to go out for 15 minutes and trim a few bushes. Yeah, I'm going to go out for I'm just going to walk over to the next habitat and talk with Joe for a little bit. No,
Call him on the phone.
This is a major decision to say I'm going to go outside the habitat. Now, if you're on the ISS, your main objective is to stay on the ISS, and you will occasionally go outside. If you're on Mars, what's your objective?
Survive.
Your objective is to go out and explore Mars.
Oh,
Okay? So your objective is not just to stay in the habitat. Your objective is to go out. You're doing this all the time.
This is where robots get from.
Yes,
Right.
robots are going to be essential. But if you're going to send robots, why not do that from Earth?
That's right.
And everybody stay home and watch it by
Right.
video.
So the LGVC, that liquid cooling and ventilation room, has 91 meters of tubing in it. I mean, it's little tiny tubes, and you got a pump that works. It's a custom fit. The spacesuits EMUs are part custom, and their part come with large, medium, and small. So the hands are can be custom made, but you have to have things that fit. They have to control the oxygen, the CO2. You got to have a scrubber. It's got to control the temperature, the humidity, and the pressure. So all this has to be contained within the suit. The helmets have a little water container in a tube so that you can drink. Because if you're going to be out there for 6 or 8 hours working on something, because it's not worth going out for 15 minutes, right? You're going to want to have some water, which of course means you need to have the diaper on because you're drinking water. Now, it is in fact the case that these tubes have leaked. Now, when you're in 0 G's and you have this leak, it doesn't go to your feet. It just floats around. You can end up breathing it. And one of the astronauts almost died from drowning because he couldn't get inside fast enough when the tube leaked. It's only happened once, but it just goes to show this is high-tech survival. If the technology doesn't work, you don't survive. Regolith clings and abrades. This will shorten the life of your spacesuit. And by the way, it will eventually work its way into the spacesuit, okay? Because you have joints. And even at 1/3 the gravity, I saw one presentation. I says, you'll be able to jump like Superman. No, you won't. Not with this suit on. It is work doing any kind of motion. And with the gloves on, there are no fine motor skills. Okay, you would do much better to have a robot to do fine finger work than for you to try to do any kind of fine finger work with a spacesuit on.
Peter Ross has said that they will be done by machines. We don't think we're going to go there. We're going to send, and the way AI is going in the last couple of years even, very feasible.
Well, we will have people who go there. We may only have one trip, and then we say this is not worth it.
it might
But-
just be one way.
Well, and it could just be one way. But anyway, so you have no fine motor skills. Every motion is an effort. I've already said that. So protection, Mars versus Earth. Mars, I don't want to make a mountain out of any one of these issues, but we have enough molehills here to make several mountains. There's temperature, sandstorms, radiation, the atmosphere issues here, perchlorates. On Earth, it's not that hard.
Yeah.
We walk up and down the
Yeah.
mountains.
Take an umbrella.
Yeah.
Wear a coat. Open a window. Put on some sunscreen. It's not that hard. Just breathe. So Anyway, you guys are getting the picture here. Energy, the facts. Four possible directions: solar, battery, nuclear, chemical. Everything I read, solar, solar, solar.
It's too far away.
Uh, well, it's going to take a lot of solar panels.
Half the planet.
They are going well. What makes sense almost if you're going to use solar is to have certain solar panels and have concentrators. So mirrors that can be made out of mylar that can focus the light. So these are light, low tech, but you still have the issue of dust storms. You still have what happens at night. So you're going to have batteries.
Yeah.
And if you have a multi-week dust storm, you're going to have to go out and clean the solar panels, and 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 how long will your batteries last? So I'm saying if you're going to do this, you need nuclear. Okay, you cannot do this without nuclear. Nuclear doesn't care if it's dark, doesn't care if it's cold, and it's going to be there.
How do you cool it?
I'm sorry.
How do you cool it? The water going through the nuclear reactor.
Well, there are ways you can cool it with sodium.
No, that's true.
There are ways to do. There are solutions to these problems here.
Plus, in the cold of Mars, that might work for you. You could use different things for coolants.
Yeah,
Couldn't use
you
here,
could use ammonia. There are all kinds of things.
Sodium works. It's been done before.
Yeah.
Nuclear generates its own heat, though, and it will be a problem with
Yeah.
the coolant if they build it right.
Yeah,
As far as
if they build it right, this can be made to work. So I'm not saying we can't do this. I'm simply saying it is a high tech survival, and every system is a life critical point of failure. Okay, chemical.
You gotta bring them with you.
Well, no, you can take water, carbon dioxide, and you can make methane, and then you get the oxygen, and then you can burn it, and so you could have a methane engine that motors along and doesn't need a battery.
Is there any use for the perchlorate? With all this crap around, there ought to be some use for
You,
it.
you would think that there might be. So you've got these four possibilities. Let's talk about this. You don't have as much sun coming in. It's 3 times more variable than the Earth. Got dust storms, dust coatings. It's easy to ship and set up, but it's going to lose 5 to 10% power per year because of the degradation to the solar panels. So if you're planning to stay for a while, you need to have lots of backups and backups to your backups. Nuclear, it's heavy to ship, complex to set up, but it is reliable. Dust has minimal effect, darkness has zero effect, cold has zero effect. And so, there are problems and challenges, but I think you're going to have some nuclear. Batteries, they're heavy, they're slow to recharge, fast to discharge. Cold reduces the power, and if the battery actually freezes, you let the battery get cold, it will destroy the battery. So it needs to be perhaps self-warming or kept in have some other power coming to warm it. They can also overheat, so you need to have a radiator in some way to handle those. Chemical, you can make methane. You can power heavy equipment, and Elon Musk is planning to use rockets that use methane. So he's planning to make his fuel for his return trip on Mars
From
and
the stuff on
from the stuff on Mars, and use that and then power his way back home. For those people who go, I guess Elon Musk will stay. If he wants to die on Mars, then he will not come back. But it's slow production. Equipment is heavy to set up, and it's heavy to ship, and it's complex to set up, which means it has to be maintained. And everything is a maintenance nightmare. Okay, no fossil fuels. Fossil fuels rule on Earth.
Still.
High-tech energy is life or death. Loss of power is usually not deadly. If you're on a
So is
life
another
support
plane.
piece of equipment in a hospital, maybe so. But this,
If you're in a plane.
in a plane, yeah. Technology is at its limits, whereas technology operates comfortably. So everything is right on the knife's edge on Mars. Redundancy is life critical. I don't want just one nuclear power. I want 2 nuclear powers.
Yeah.
Okay.
Three.
I don't want enough solar panels to meet my minimum need. I want 2 or 3 times that.
I guess they cover half of the time.
Yeah, and backups. I want stuff in reserve.
Can't just go to the drugstore and get a new one.
No. That's I'll bring out we wheel out the generator and hook it up to the house and
Yeah.
whatever. Okay, P.S. A little P.S. about gravity. You're not going to change the gravity. Okay, so you could get a habitat that's got decent air pressure in it and whatever. However, you're going to solve it. You are not going to solve the gravity issue. Bone loss estimated at 6 to 12% per year with muscle atrophy. This is another reason why you're not jumping over your rover, your car, or whatever, because it's 1/3 the gravity. You're not going to have the muscle strength. Probable vision changes. That's one of the things that all astronauts on the ISS have reported, because when you're in 0 G, you don't have any gravity pulling your blood or your fluids down, so the fluids redistribute. And what that happens in your eyes is it changes the shape of your eye, so that you didn't used to need glasses, but you need glasses. Okay, but you're not going to wear the glasses in the spacesuit, so you work with poor vision when you're doing the UVA. Okay,
That's dangerous too.
well, they practice and they're trained.
Does that
But-
all of this, can it be reconstituted when you come back to Earth? Like the bones when they come back to Earth, can the bones gain their strength again and your vision get straightened out, or do they have
Some,
to,
yes, some.
do they have to go through medical treatment to?
Well, when you come back to Earth, your bone loss can be um, reversed to some degree, but it does not seem to go back to the way it used to be. Your eyesight can come back, but not everybody's. Okay, so there are things that change that can become permanent. So on Mars, this is not 0 gravity; it's 1/3, but you're still going to have some of these things. Digestion slows. There's bloating because gravity actually works. It affects your digestion. Um, just lots of little issues. Survival on Mars, kind of coming toward a summary here. There are no low tech systems. High tech power, high tech water purification, high tech oxygen cooling, spacesuits, regolith moving equipment, methane production, airlocks. Everything is high tech. Supplies are critical. If you run out of oxygen, we have a problem. Your MOXIE unit stops producing oxygen, we have a problem. Equipment parts, we better have enough 3D printers and enough material to print parts with, so that we can make anything that we need. I'm sorry, your motherboard went out. Oh, we don't have one of those to be 3D printed. You are going to be going through filters incredibly fast. You better take lots and lots of filters. And gaskets. Gaskets, the regolith is going to mess up your gaskets. Your diapers, your maximum absorbency garments. These are not reusable. So if you don't have one, you can't go out. You need to have a complete supply for every person, for every extracurricular activity that you do.
You need a spaceship just for you to jump.
And you need food. Okay, and you probably ought to have spare liquid cooling and ventilation garments in case one of them starts leaking. You ought to have, in other words, you need backups and backups to your backups, and this is not Earth 2. Okay, a couple things you will never hear said on Mars. It's a lovely day outside. It's raining. Will someone let the cat out? Look, there's a hawk in that tree.
No hawks
Let's
in the
grill
trees.
steaks tonight. You kids want to have a picnic? Oh, she's out sunning by the pool. Let's get a pepperoni pizza. Let's go fishing. I need to plow the back 40. Things you might hear said on Mars. The winters may be 6 Earth months long, but at least the summers are freezing. How many months will this sandstorm go on? Solar storm alert. The airlock is leaking. Do we have any duct tape? Attention all Marslings. The meteor shower will start in 2 hours. Our mag supply is running low. Only critical outside activity until the supply ship arrives next week. So, I thought I'd close this out with two quotes by Barack Obama. State of the Union address, big publicity. I want Americans to win the race for the kinds of discoveries that unleash new jobs, pushing out into the solar system not just to visit, but to stay. Last month, we launched a new spacecraft as part of a re-energized space program that will send American astronauts to Mars. This is okay. But then, in a much lower key, here is where he's really honest.
Right.
Okay, even after nuclear war, Earth would still be more hospitable.
Yeah. Every city on Earth is destroyed, but it's better than Mars.
Okay, so back to this. God, the Bible says that God formed the earth to be inhabited.
Yeah.
And all the evidence says here, from the survey of exoplanets that we did last year, and this case study says this is God's doing, that we have this incredible planet. Enjoy the trees, enjoy the breeze, enjoy the rain. Praise God for all that. So here are some artist conceptions, just some pictures of living on Mars. I'll comment.
Oh, how pretty.
Yeah, notice all this. The big greenhouse like that, the radiation will kill the plants.
Yeah.
That looks more like a moon.
Okay.
That's the moon. It might be better.
Yeah. So this is, and notice at least the realism over here on the left, where you have the habitat that's all covered in regolith. That's probably realistic. Very nice, clean solar panels. They must have just been installed because they were a month old. Here's a habitat that is supposed to be inflatable, I believe. Here you've got one. I don't know why they have windows in there, because the concept here is that they would have all these interlocking structures, and then they would build, make bricks out of regolith, using on-site materials, and their way you got a lot of money and a lot of brains trying to figure this stuff out. But then you would put protection over this. So you look out the window and all you see is your protective wall. So I don't know why you would want to do that. This is what it might look like after you got everything all covered up. Okay, so this is, open up the window, let the merry sunshine in. I don't think so. This is just a picture of one crater that actually, this is not artist conception. This is a real picture of a crater that has water in it. Okay, and it's not, again, it's not clean water, but it's water. Now this is a real dream.
Oh, yeah.
Do you know how much oxygen and nitrogen it would take to fill up that dome? That is not going to happen.
And again, the radiation with the
Yeah,
soil
and the
plants.
radiation, and structurally, just as an engineer, there is no structurally material which is strong enough, uh, transparent, and radiation proof to do anything like that. Okay, it's just it is unobtainium.
Is that a drone up there?
Yes, that's a drone over here
How
above
does
this
it fly
other.
with that kind of atmosphere? There's nothing to
There-
look back against.
They do have a helicopter program right now on the moon, right?
Yeah,
They had one that flew around just with an
It worked.
atmosphere.
Yeah,
It
it worked.
Yeah,
It was pretty amazing.
Yeah, it's pretty amazing. I mean, it was small, but yeah, it got pictures and it hopped around. And it's a good thing. So here's again another totally unrealistic thing, and you've actually got, it looks like wind power over here is what it looks like.
Wind power.
I don't think that's going to be working very well. It shows all this piping here. I don't know how it's heated. I'm not sure what's going through it, but
You have to bury everything, wouldn't you?
yeah, it is not going to be pretty. Again, not this at least has some sort of structure to hold up the clear panes, but every single pane that you have has to be sealed. Every joint has to be sealed, and if it starts leaking, you got to find the leak. Okay, this is almost realistic.
Yeah.
Okay, the thing that's not realistic is the short um, airlock. I think it needs to be a much longer airlock. This is possibly realistic. You know, no windows. Um, not realistic. Um, Maybe to start, but you can't. You need much more protection from radiation than what those things will give you. So the point here, again, as I said, is not that we can't go to Mars. I'm not saying that we shouldn't go to Mars.
You're not going to go.
I'm not volunteering.
Just the percolate's enough to put me off.
Um,
A poisonous substance everywhere. Think about that.
yeah,
Yeah.
the planet is trying to kill you.
You know, Hugh Ross, in his books, he wrote a series of things that have to be fine tuned for life to exist. Right? You're familiar with